And when you hit my labs once and twice, this is what happens. Okay, so you go to your handy dandy shield, and there's the shield right there. If you can't see it, you need to move or you need to look for it. It's right beside the star. It's in the address bar. You right click on it and hit load unsafe scripts. If that doesn't work, you go right click on it again and hit allow pop-ups. Now, 3 of my Math 120 students yesterday came up to me after class and said, we can't get in. We've tried. And I looked, and they all had laptops. And guess what kind of laptops they had? Anybody want to guess?
The MacBooks.
Yep, exactly. I said, try it on my computer. And it went on. All 3 of them got on just like that. Don't ask me. I'm not an iPhone person. I'm not a MacBook person. I don't like Apple. Never have. Even when it was coming up, I didn't like it. Okay? That doesn't mean I'm criticizing you to do. That's not what I mean. I just don't know anything about it. What I would do if I was you, somebody said in my 120 class last night that you need to go and get Chrome at some app, Apple app, Chrome, Google Chrome. Evidently Safari has issues with this. I don't know. But you're going to have to take that up with technical support at MyLabs Plus because I have no idea. Anybody got an Apple that tried it and it didn't work? What did you do?
What did I do?
Yeah.
So I did the exact same thing because I've had MyLabs Plus, but I had a Dell, like a desktop at my house. And it would show the star, and then it would show what you showed where it had the shield, and it would work. But like for the MacBook, it doesn't show anything. It just goes blank, and it just sits there.
So are you just going to use the Dell? Or
yeah, I'll probably just use the other one at my house. It's
okay.
Fine.
You might want to call that 1-800 number or 188 number and see if you can figure out what to do. See, do you have the Google Chrome on your?
Yep, I have the Google Chrome. I've had that on it for a long time.
Did you try that?
It doesn't do anything. Yep, because I don't use Safari. It's too slow.
Okay, well, I have no idea what to do except either the 1-800
I mean, just
number,
use the desktop, I guess.
or use a regular normal computer. I'm sorry, a Dell or a other computer than a iPhone. I guarantee you, if you go and buy something from Apple, guess what? I bet it'll work. That's why I don't like Apple. My son and my daughter, I will not buy them an Apple laptop because I don't want them to go through that. They got these iPhones, and everything they want to get this new, they got to pay for it. And I just
got a good deal on it. I paid $200 for it.
Well, that ain't bad. But do you have to pay for everything that goes on it?
I think it's free. The Google Chrome was free.
I don't trust them. Anyway, that's just me, but I'm stupid. Anyway, okay, so that's how you get on. Now, once you do, and I'm saying this for the 3rd day, once you go through Blackboard and get on, then I want you to go and pull up tctc.mylabsplus.com, okay? Because it's a whole lot easier and it's a whole lot dependable because you can't depend on Blackboard. That's why I do not use Blackboard. And how many times have I said that in the last 3 days? 5 or 6 times. I do not use Blackboard. Okay, so boom, there it is for the 6th time. All right, now, done with that. Now let's go back to the whiteboard. Now, I had 3 text messages yesterday and not one. I had 3 text messages and 3 emails yesterday from different classes. Guess what they were asking? Anybody want to guess? When is the homework due? Have I even started on math yet?
It's due when the review happens.
Exactly.
Or before the
review. Have I even started on math yet, though?
I think you said something briefly about it. I just
said
remember
y'all need to read, but have I even started teaching math yet?
Oh, no.
I haven't even started, and I'm not just this class. I haven't taught math I don't teach math until the third or fourth. Today, I will actually start talking about math. All right, now I'm going to go over this again because I'm going over it again in the 155 today. I'm going over it again Monday in all my other classes. I meant Tuesday in my Tuesday-Thursday classes. And I've also written an email to my online class because my online class sent a text message. When is it due? You don't need to worry about that yet. Okay, now, if I start today, and what I mean by starting, if I start talking about 5A, I'm going to go through and I'm going to do problems, and I'm going to, write stuff on the board, and I might get done with 5A. If I get done with 5A, that means that you need to work on 5A homework. Then you send the questions. Did we go over Ask My Instructor?
Yes.
Okay. You send the questions on Ask My Instructor. We start class Tuesday or Monday or whatever y'all come back. We start class. I go over those questions, and then I move into 5C. When I get 5C done, you what? Work on what? 5C homework. You with me? Everybody with me? Now, when you get 5C homework done, you send questions. I go over those questions, and I move into 5 what?
E.
5E, as in echo. Y'all see the pattern? So the homework is due at the end of right at the review test. But when should you be working on the homework? After I what?
Go
Cover.
over it in class.
So let's say, and just for purposes, let's say that today I cover this. And somebody tell me what Monday next week is. Somebody look on your calendar. What's Monday of next week?
The 14th.
Okay, I heard. Somebody say it. When's
It's the
Monday of
14th.
next week? What?
The 14th.
Thank you. There's 14th, and then 2 days after that is what? The 16th. 2 days after that is the what? 18th. 2 days after that is the what? 20th. 2 days after that is the what? I'm not thinking about Saturdays. I'm just trying to show you how this is done, okay? 22nd, and then the review looks like it's going to be on the 24th. Okay, now I know there's Sundays and Saturdays in there. I'm just saying you need to use your calendar. Okay, what I'm trying to get you to see is, and I'm going to do this in all my classes today, and I'm going to do it Tuesday. Okay? When do you need to start worrying about the test? I mean, the test is going to be what? Probably toward the end of the month. Can everybody agree on that? Yes or no?
Yes.
Okay. So when I get to this point right here, what will I do? I'll pull up the test. Didn't we talk about the test? Did we talk about the test and it has the bonuses on it? Did we go through the test?
Yes, we did.
Okay. What did I tell you? After I pull up the test, I will say, okay, today is the 7th. That means it's going to be due on the 14th. So I'm going to put the 7th and the 14th as the beginning day and the end day. And then I go through and I say, okay, well, if the test starts on the 7th today, and I'm going to always give you one more day to send in questions from the homework. So that means the homework is going to cut off on the 9th. Okay, does everybody see what I just did? Okay, let's take, for instance, today. Let's say that I went through the test today. All right, we done finished chapter 1, okay, or unit 1. Today is what? The 11th?
Yes.
Okay, we just finished going over the test. I said, okay, today's the 11th, so the test, I'm going to set the test to be over on the 18th. Okay? Now, the homework, since most of y'all have already done it, I'm going to give you one more day to send in questions. And I'm going to give you one more day. So that means today is the 11th. What's Monday? You said Monday was the what? The 8th? What?
14th.
The 14th? Okay, so that means that homework is going to be due on 1/14, midnight. All my assignments close at midnight. So therefore, you can come to class Monday and send in questions on any homework that you have questions on. But I only give you that one day. This is the one day right here that you have to send in any questions on homework. And you still have how many more days from the 14th to finish the test? You still got 4 days. Do you see how I do it now? Okay, yes or no?
Yes.
Does everybody see how I do it? So, when will you see dates on the test and the homework? When I do what?
After the review.
When I do what?
Review.
When I review the what? Test. When I review the test, that's when you're going to see the dates. When? Okay, now this is the question. This will really get you. When am I going to do the review? After what? The last section of work. Just follow that same pattern every unit. Okay? Who's got questions? Now, the ones that have problems with this are the ones that wait until the what?
Last minute.
They don't know when to start. See what I'm saying? They don't know when to start because they got to have a date. I got to have a date. No, you work on 5A when I go over 5A. You work on 5C when I go over 5C. That's the way it's supposed to be done. Okay? And I mean that for everybody because I've got, like I said, I got 2 or 3 texts and 2 or 3 emails from different classes. So I'm going to go over this again in every single one of my classes. Okay? Who's got questions on anything having to do with anything so far? Okay. All right. So let's go to our handy dandy book. And you don't have to have a book, but I'm going to pull it up. And we're going to start on 5A. So let's go ahead and get your notebooks out. And I will highlight what needs to be highlighted. If I say it needs to be highlighted, then that means you need to what?
Write it
You need to
down.
write it down. Now, since we're only talking about Oconee campus and Easley campus, because Anderson just quit, let's start with Oconee campus. Have you had probability and statistics before?
Yeah, in high school.
How long ago was the class?
Like, how long have I?
How
How long
many
has it been
years
since
since
I took
that
the
class?
Shoot, I took that in junior year. So that'd be senior, 1, 2, about 3 or 4 years ago.
Okay. Okay, let's start on the right side, over there beside Miss Riddle. How many at the Easley campus? Have you taken probability and statistics before?
Yes.
How long ago?
Last semester.
Okay.
I got
Miss Riddle. What? Go ahead.
I got a D, so the credit didn't transfer.
Okay. All right. Miss Riddle, how about you?
I did not. I took calculus.
Okay, good for you. All right. I know they tell you have to take probability statistics. That's a bold-faced lie. They only tell you to take it because they don't want you to take algebra and pre-calculus because a lot of people fail that. So that's why they want you to take the watered down. They want you to take the probability and statistics because they don't want your grades to go down. That's why they don't want you to take pre-calculus. So good for you for taking it. How about you beside Miss Riddle? I'm learning y'all's names. Y'all just gonna have to get used to it.
I took it fall semester of 2017.
Okay, so that means last year or a year ago, maybe?
Year
Yeah,
before.
about a year ago. Okay. Yes, going around.
It's up to 4 years ago.
How long have you taken it?
Up to 4 years ago.
Okay, you've had it 4 years ago?
Yeah.
Okay, how about you?
I took it 2 years ago.
at high school.
Okay. So everybody has had it except for Miss Riddle. Okay. All right. Well, I just wanted to know because sometimes it helps for the teacher to know, the feeling of. But it sounds like to me that a lot of people have had it more than a year ago, so it doesn't hurt to go over some of this stuff. All right. The purple box or the mauve box, whatever you want to call it. I want you to write those two definitions down. Statistics. But I want you to change one thing. I want you to change this S to a lowercase s. Okay? Capital statistics, capital S statistics, is the science of collecting, organizing, and interpreting data. Okay? So when you see a capital S, that means the science, the math. Okay? When you have a lowercase s, that means the data, meaning what the numbers represent. In other words, we'll get to that in just a minute. It'll make more sense when we get to parameter and statistics of a population and a sample, but you don't know that yet because we hadn't talked about it. So just write that down and take my word for it. Uppercase statistic is a science. It's the whole field of obtaining, organizing, and interpreting data. Lowercase statistics is the variables that are used. You can say that if you want to. The variables that are used that are usually letters of the alphabet. Letters in formulas that is usually letters of the alphabet. So I'll put an example here for you. X bar is equal to the sample mean. Or the average, sample average. And S is equal to the sample standard deviation. I can't spell and this thing won't erase because we have no training on it. We've had these boards for 2 years. We haven't had any training on them yet. That's why nobody uses them. It's really sad. Standard deviation. Now, you'll see when we get to the parameters in the population that they change. Now, that's from a perspective of sitting in an audience and seeing a presentation on statistics and knowing the difference between the two. That's why we need to know what's what, and we'll get to that in just a few minutes. Okay? So that is a test question. You could see that on a test. What's the difference between a capital statistic and a lowercase s statistic? Okay? So that's a good question. Good to know. Next. There we go. Here, I figured we'd get to it right afterwards, but I'll bring this down a little bit so you still have the sample mean as X bar and the sample standard deviation. Those are what we call lowercase statistics. Lowercase means they are variables used for the sample. These are the statistics. Statistics. There we go. Lowercase statistics, not uppercase. All right? These are letters used or variables used in formulas for the sample mean and the sample deviation. And that's what that says right here. Remember, S goes with S. Sample goes with lowercase statistic. What is a sample? Well, somebody tell me what you think a sample is. In layman's student terms. You don't have to get mathematical on me. Just tell me what a sample is.
Like an example of something?
An example of something or a small part of something, right? If you take a sample of, you go to the Walmart or whatever, I don't know, and they have these little samples that you eat. It's part of the package, right? So if you got a package of potato chips and they hand them out and put them in little cups, cupcake cups, and you eat one of those chips, you are eating a what? A sample. It's part of the whole. The whole is called the population. So if I want to know how many people are in the Marlboro Club at Tri-County Technical College, that would be the population. Okay? The population would be Anderson campus, Pendleton campus, Sandy Springs campus, Easley campus, Oconee campus, all the campuses. That's Tri-County Tech. But the sample would be sampling the people at at Anderson campus. Okay? Or just doing a survey at Easley campus. Or just doing a survey at Oconee campus. That would be the sample. So, why do I want to use the sample? Why do we want to use the sample to predict the population? Does anybody have any idea? Well, what's the two most important things in all of our lives? One starts with a T and the other starts with an M.
Time and money?
Say it.
Time and money.
Time and money. Good job. Your parents did well. Okay? Time and money. If I do the sample, I'm saving time and money. Why?
Because you're not doing a huge population, you're just doing a piece of it.
I'm doing a piece of it. I'm doing a small population. So my goal in probability and statistics, my overall goal in probability and statistics is to take the numbers from the sample and predict the same numbers or predict the same values or whatever needed for the population. Example, how many people at Tri-County Tech are in the Marlboro Club? Okay? Or the Camel Club or whatever you smoke, okay? I can't ask everybody at Tri-County Tech. So I'm going to go to the Anderson campus. And I go ask 100 students at the Anderson campus. Are you a smoker? Blah, blah, blah. And 70% say no, 30% say yes. Then I go through and take that 30% and I run it through a bunch of calculations that you learn later on, that you learn later on in Math 120, which is a sister course to this. Okay? And I say, well, I can say with a 94% confidence level that 28% of the population at Tri-County Tech are in the Marlboro Club. Now, why did I go from 30 to 28? Because the numbers and statistics, when you crank out the numbers, it may give you a different number. But that's a prediction, okay, for the population. And I didn't have to go through and I didn't have to ask everybody at the Pendleton campus, the Anderson campus, the Easley campus, the Oconee campus, and so on. Okay? So, whenever you're dealing with formulas, whenever you're dealing with a presentation, let's say that I give you a presentation. We're all in a work setting. This is not school, and y'all are working at two divisions of this company, and the main company's right here, and I'm the CEO, and I'm giving a presentation. And I throw up the safety. We got to work on safety. Right here, you see X bar is equal to 15 accidents. And mu is equal to 18 accidents. And you go, wait a minute, X bar, that's a statistic. So he means that's the sample. Yes, the sample. All right? If I say that X bar is something, you know as somebody that's looking at something, he's talking about the sample. And when he said mu, that's a Greek letter. Greek letter, right here. Parameter. Greek letter. And if you see a Greek letter in a presentation of statistics, you know that Greek letter is in reference to the what? What does it say in front of parameter?
Population.
Population. So a parameter is a variable used in the population calculation or formula. Now, why would you need to know this? The only reason you need to know this at this level is if you're presented something or if you are presenting something, like a report. And you don't want to show your ignorance by saying, what does that X bar mean? You don't want to do that. Now you know. The X bar, since it's a letter, it means that you're dealing with the sample. If you see the Greek letter, mu, gamma, sigma, any of those letters, which you're going to see in this class, if you see those letters, you know it has to deal with the what? Starts with a P. I want you to say it. Huh?
Population.
Population. So regular letters go with the sample. Greek letters go with the population. And that is a test question.
Say, please come again.
Say again?
Come again.
Yeah, she wants you to say it again.
Letters.
Oh, you want me to say that again? Okay?
Yes.
I'll write it. How about that?
Okay. Okay.
Y'all are just so blessed to have me for a dadgum teacher. I tell you what. All right. A sample means that I'm going to be dealing with lowercase statistics, which means variables in the formulas that are letters, like X bar and S. Okay? So the sample deals with statistics, lowercase s, meaning the variables used in the formulas for the sample. And the thing you got to remember here is this. S goes with what? S. The population, which is your bigger number, is dealing with parameters. And parameters are letters used, variables, letters, whatever you want to call them, variables, letters used to deal with the formulas in population. Mu, I write that wrong. It's supposed to be written like this, but I write it backwards. So that's mu. Or here's sigma. It's a 0 with a little pompadour on top, and that's sigma. Mu means the population average, the population mean, where X is the what? Sample mean. S is the sample, what? Standard deviation. And sigma would be the what? Population standard deviation. How does that help? Does that help?
Yeah.
And what goes here? The S goes with the S, but what goes here? The P goes with the what?
P.
P. Population parameter, sample, statistic. So let me give you an example of where this is applicable. I'm giving a presentation, and I'm got a bunch of stuff up here, bullet here, and I got a bunch of stuff right here, and I got to do this, and now I've got a table right here, and I got this, and this, and I got stuff written here, and I got stuff written here, and I got letters or numbers here, and here, and here, and here, and then I've got outcome. And I say mu is equal to 15 accidents and standard deviation, don't need to do standard deviation. Well, I could. Standard deviation is equal to 2. And then I go over here and I say x bar is equal to 18 and s is equal to 1. And that's my outcome. And you need to say, okay, what he's saying is the population accidents is 15 and the sample is 18. That's what you're supposed to be able to get from the sample statistic and the population parameter. You just need to know the difference between the two and what they mean. Okay? This is the population numbers, which means the whole company. And this is just one little part of the company, say a branch. Okay? Branch and whole company. Everybody understand that? So when you see mu in the book, you know that's with the population. When you see S, you know that's, or X, you know that's the sample. And that's the only thing you need to know. That's the difference between the two. If you see a Greek letter, that has to deal with the population. If you see a regular letter of the alphabet, you know it has to do with the sample, which means the small portion. Yes, no, maybe? Capiche? Okay, nobody's going to say anything? Okay. Miss Riddle, do you understand since you talked to me? Nobody else does. Do you understand, Miss Riddle?
Yeah, that helped out a lot.
Okay. I talk to people that talk to me, okay? If you don't talk to me, I'm not going to talk to you. All right. I'm just kidding. It's a joke. You got to have a sense of humor. All right. So let's go back to the book. So make sure you know that. So the purple box there is very important. So you need to write down page 295, purple boxes. If you don't have a book, there's the page number right there, 295. Purple boxes. I'm sorry, mauve. However you want to say it. Next page. Next page. They're telling you still about population. They're doing all that. I'm not. Okay. Right here, page 298. What is a random sample? Now I'm going to write the definition of a random sample. I'm going to write a layman's definition for a random sample. Here we go. Well, first let me give you an example. Let's say that I take each one of your names, put it on a yellow Post-it, just like this one, with my black pen, right here, and I write your name, first, middle initial, and last name on this yellow Post-it, okay? Okay, and black pen. And I put your first, middle, and put it in a goldfish bowl, and I pick one of these out of that goldfish bowl. What is that called? That's called a random sample. Why? Anybody want to take a guess on why that's called a random sample?
Because it's completely random.
Completely random, meaning everybody has the same what?
Chance.
Chance. Write that down. Random sample means everybody has the same chance. And that is the key word for random sample. Everyone has the same chance. Random, I can't spell. Random sample. Everyone has the same chance. And this is where we get into a little bit of the two words bias and neutrality. I'll just say neutral. Oops. Neutral. Bias / neutral. Bias is B-I-A-S, and neutral is N-E-A-U-T-R-A-L. Now, a lot of you say, well, what does that have to do with bias and neutral? The whole purpose of statistics and probability, or probability and statistics, is for you to be right down the middle as far as having an opinion. Okay? The best way to explain that is a referee during a ball game or an umpire. Okay? Most people, except for Clemson fans, most people see that referees are neutral, except for Clemson fans. Okay? Clemson fans believe the referees are always against Clemson, and the commentators are always against Clemson. But most of the time, referees are down the middle, meaning they just call them as they see them. Okay? Now, they do make mistakes. I agree they do make mistakes, but they don't pull for any team. Okay? They're just like a judge. A judge is very what? Neutral. You may not think they're neutral, but they are. Okay? Because that's one of the things about being a lawyer. You have to spend years and years of being a lawyer to discern between what you want, what people want, and the law. Okay, even though some people don't believe in the law, that's Hubert, don't go there. Shut up. Okay. Anyway, to make this long story short, what if I was to take one of those yellow Post-it notes and I was to change it to a pink one? So there's 5 or 6 yellow ones and a pink one. Is that a random sample?
No.
No. Why?
Because it's biased to one color as well as another
something has been entered into the fishbowl that may affect the person drawing the name out. Okay? What if I folded? What if all of them were yellow and I folded one 15 times and the other ones I didn't fold at all? That is not a random sample because something is going to affect the drawing of that name. Okay, that's where the neutrality and the uniformity and the non-bias come in. Okay, can you lead with a question? Yes. And that's where we get into all of these surveys that'll say, you don't really like the President of the United States, or you don't really like the mayor of the city. That's a leading question. You don't do a survey with leading questions. When you get into college and you get into master's degrees and you get into research classes, they will teach you how to write a question. Because you can't write a question, you don't believe in this, do you? You can't do that. That's leading. Okay? And the main thing with statistics is you have to be right down the what? The middle. You can't be biased. That's why so many people are talking about the media, not just the media on TV, I'm not talking about that, but also like newspapers and magazines and things like that. When they show a picture and it's not accurate, it's not an accurate representation. We get into that at the end of this unit, okay, or at the end of this section. It's called biased statistics, okay? And there's a rule in statistics. There's the truth, then there's not the truth, and then there's statistics, okay? There's an old saying, and I know I got it wrong, but if you Google it, you'll see it. It's an actual saying. There's the truth, there's lies, and then there's statistics. I think that's it. But the whole point is, some people use statistics to lean a certain way, and you can't do that. And that's where it starts. It starts with a random sample. Now, they give you, oh, hold on a second, I got to check because some of y'all are going to like blow up here in the next few minutes. Let's see, what time is it? I got 9 minutes. So I'm going to cut it off at 4 minutes so y'all don't explode. But anyway, if you're talking about statistics, you got talking about neutrality, and let's go down. And here are some different types of sampling. Okay? Go ahead and just write the names down, and you can go back and fill in the blanks later. There's a simple random sample, which we just talked about. That's putting your names in a hat. Everybody has the same chance. Systematic sampling. That's used a good bit. Put a star beside that one. Why is that one used a good bit? Because it is a way to have a random sample but get through all of the sample quickly, picking every 10th person, picking every other page in the phone book, picking every 100th person in the movie theater. Okay? That's a way to have a random sample and get through the whole population or the whole sample without having to interview every single person. So I would, out of all of these, I would highlight simple random sample and systematic because those are the two most used. The least used is convenient sample. Why is convenient sample? Okay, I want everybody to listen to this story, and I want you to tell me what's wrong with it. I'll let y'all finish writing first. Now, what if I worked at a radio station and I was a DJ? Okay? And I worked at a radio station, I'm a DJ, and I decide I want to find out how many people are listening, to my DJ, and I work at a rock station, rock and roll. And I send out across the airwaves, I say, how many of you out there like rock and roll music? Why is that a convenient sample and why is it not accurate?
Because it doesn't have another part of the sample. It's just that one.
Well, what are you saying? Because
if it was say, do you like rock music or country music? There's either yes or no for that, but if you're just asking for rock music, it's just going to be a yes or no.
Because I'm a DJ where?
At a rock place.
So what's the outcome going to be?
It's either just going to be a yes or a no, I guess.
No, all the people that call in, if I work at a rock station and they're listening to me, how many of them are going to like rock music? Huh?
Most of them.
Exactly. So what can you say about a convenient sample? It's probably going to be the least what? Accurate. So put convenient sample is probably going to be the least accurate. Stratified sampling is when you have groups. Let me give you an example of a stratified. I go to a voting precinct and ask people if they are Democrat or Republican or other, and then I ask them, do you believe the grass is green in this yard right here, or whatever? I ask them something totally arbitrary. That is called stratified. Why? Because the group I'm asking is divided into what? Several groups. Democrat, Republican, and other. Okay? That's a stratified sample. I group people, but they're already divided into groups. Could you do it with male and female? Yes. Could you do it with age groups? Yes. If they are some kind of a group and you're asking them, what color is the sky? Then that is a stratified group because you're grouping them into their own groups, which is used a good bit, especially during political seasons. Okay? A lot of people are polled in stratified groups during political seasons. Like 2020 coming up, you're going to see a lot of polls. And it's going to be men and women. It's going to be black and white. It's going to be red and yellow, black and white. I have to say that because everybody's different color. Red, yellow, black, and white. And whether you are this or that, or whether you were this or that, they put it into groups to see who's voting for who. Okay? So one of the main things you need to get from these random samples, you've got to be neutral. You cannot be biased. Let me give you an example. I'm going to do a survey for the 2020 political race on blah, blah, blah person. Okay? And I went across the United States and I have found that political person A is going to win by an overwhelming amount. I went across the United States. Okay? What I neglect to tell you is I started in South Carolina, went to Georgia, Alabama, Mississippi, New Orleans, Texas, Arizona, and New Mexico, and California. Did I go across the United States? Yes or no? Did I physically go across the United States? I went from South Carolina to California. Did I go across the United States?
Yes.
Yes.
Yeah.
But what's wrong with that? What's the South considered? Conservative. Right. It leans to the right, correct? So is this a good random sample?
No.
But did I tell the truth?
Yes.
I went across the United States. Did I? Did I not? Yes. That's how things can get twisted in statistics. You've got to watch what you're reading and what you're listening to. And I'm not talking about on the media. I'm talking about in the dadgum boardroom. When you're in a meeting of department heads or when you're in a meeting, period, you've got to really watch and think about and listen to who they interviewed or how many people they interviewed. Okay? All right, I got to shut up. All right, let's mark down 298. That's where we left off. Now, should you be doing any homework tonight? No, you should still continue to read because I haven't completed this section yet. So you're not responsible for any homework. The only thing I will ask you to do is continue to get logged on, continue to decide what book what you want to bring to class, make sure your supplies are good, and also get on to My Labs Plus, get that done, okay? And continue to read. Continue to read that chapter 5. Who's got questions for me? All right, y'all have a good weekend and keep between the ditches. Some people, y'all.